Good day. The topic of today's lecture is basic programming conceptual level. My name is Mikalai Yatskou. I am associate professor from the Department of Systems Analysis and Computer Modeling, the Faculty of Radio Physics and Computer Technologies, Belarusian State University. This lecture was prepared with my colleague from the Faculty of Biology, Department of Genetics, Vasily Grinev. And today's lecture will be devoted to the R language for programming. And the title of the lecture is Introduction to the R Programming. So, the outline of the lecture. We will consider three questions. The first one is history of R language. The second one is data types that are used in R language for presenting data structures. And third question is about the Bioconductor project, which is used in the bioinformatics community. And we start with our first question. It's history of R, and let us consider some important elements. And we start. So the essence of modern data analysis is the interactive process of research, visualization, and interpretation of information data flows. Dozens of application programming packages are used now in practice. Many of you familiar with such program packages. And you may often ask a question, what software for data analysis should be used as the best one? Of course, you can select one or that, but one should take in account the following things. So first, the specifics of the solved problem that need to be solved during your analysis, then the efficiency of development and debugging of processing algorithms, then the cost of the software license. If you don't have too much funding opportunities, then of course it's better to find some open source facilities. And for example, personal preferences. It means that your basic experience while you're programming. Okay, many popular commercial packages for data analysis exist in the market. For example, I can mention some indeed very fashion and hot one, like MATLAB, Maple, Mathematica, SPSS, Statistica, S+, Deductor. So they allow combine different type of analysis, have access to intermediate results, produce high performance computing, and complete the final reports in required form. So they are quite nice, quite powerful, quite fast, efficient. But of course, another question is the price for this and opportunities related with distribution of the results. So we can use alternative non-commercial packages like Python, Scilab, Veka, or R. And as I noted at the beginning of my lecture, we will speak today about R language, programming language. So the argument for using R are following. It's constantly developing statistical platform of general purpose. It's used in leading university research centers and worldwide largest companies for research computations for creating huge information projects. It's also standard for teaching of statistical disciplines and also for journal publications. It's informal communication language of world scientific statistical community. As you can see, we have quite a number of arguments to use it. Actually, again, going back into the history, I should mention that R is actually a dialect of programming language S. And going back to history of S, I should mention, of course, the name of the developer. It's John Chambers, who worked at the time at Bell Telephone Laboratories, and who proposed to use this philosophy of the language to solve the data analysis questions. So the language is based on the principle of data analysis, not of programming. It means that we need to simplify data analysis and to make your program for yourself and not to write programs for others. And so John Chambers said that the main goal is to create an interactive environment in which the developer doesn't feel like a programmer. At the same time, the development should be integrated into the working module of software packages. And again, the philosophy of S, from interactive work of analysis in command line, writing traditional programs by professional programmers. So, of course, the first what we need to do, we need to install R. And you can simply download the installation package from the CRAN website, and the basic version of R contains some important packages like base, util, stats, datasets, and so on. Of course, it's recommended to connect additional packages like boot, class, cluster, and so. I would not explain the contents of these packages, I just want to say that they are very important for statistical analysis, for biological and bioinformatics analysis. And summarizing these packages, I would like to say that each year we have more and more packages developed and openly distributed. For example, in October 2017, more than 11,000 packages were developed and distributed. Many packages for biological and bioinformatics data analysis are collected and developing under the project Bioconductor, which we will consider in my further slides. Okay, let's consider some advantages and disadvantages of R. Two advantages, I can say that it runs on any computer platform and operating system. Frequent update and active development. It integrates a large set of ready-made software tools convenient for development of own algorithms for data analysis. And open help from scientific community on forums in solving almost all technical problems. So you can see it's quite helpful, and you are in a big club of R users if you choose this programming language for your research. And of course, we also have some disadvantages. I would just simply count them. It's the aging technology of programming, limited possibilities for creating and supporting dynamic and 3D graphics. Also, objects are stored in physical memory of computers, which quite slow down computing. However, these problems are solved from release to release. Also, the work from command line. So the background information is written in dry language. Okay, we go to from history to next question is data types, and I would like to mention basic elements that are used to present data. They are called objects. So there exist 5 atomic classes of objects. So first one is character, numeric, integer, complex, and logical. So these objects are used to present different data types. The basic object is a vector. A vector can contain objects of only one atomic class. So you can see here an example of R code which shows how to assign the value 1 to the variable x. So x is equal to 1. If we just put x and then it will be printed, the content of this variable is 1, and 1 in square bracket says that it's a vector of element 1. Okay, the next important elements or group of elements are constants. Constants in R are treated as objects of the class numeric. To obtain a constant of the class integer, one must specify L at the end of the number, as it's shown here. So we have number L, which is assigned to 25. So we have 25 of class integer. The next important constant, which are often used in your data analysis, is infinity. So infinity, and it's shown by the reserved constant inf, and again an example. So if we divide 0 by infinity, we have an object which contains one element that is equal to 0. Okay, the next important constants that are used by data analysts are NA and NaN. So NA are abbreviation from not available. It's also expressed missing value. It's used to indicate missing values in the data. And the second variable is NaN. Not a number. It indicates an undefined number or not a number. And typical example when you can get this type of constant when you divide 0 by 0. So at the end we have an object which contains just one element, NaN. The next important constant is null, presents a null object. It's often used when the return of value of expression function is not defined. Okay, the next one important constant is pi, 3.1415 and so on. These constants are used by mathematicians, statisticians, and also by biologists. Okay, object attributes. Objects are characterized by attributes that can be considered as metadata for objects. Not all objects have attributes. Attributes are used to simplify the understanding and description of objects. An example of this, I can note names, dim names, dimensions for matrices, arrays, and class for example, for integers, for numeric objects, length, and other user-defined attributes. Very important functions that you can use from R is function attributes. So this function for assessing and changing object attributes. And you can see a simple example in left square box. So I create a matrix with help of function cbind. So this matrix contains 3 rows and 2 columns. So in first column, which has name A, I have 1, 2, 3, and the second column, which has pi, just copies of 3 numbers pi. If then I would like to see what are the attributes of this variable, with this matrix X, I write function attributes, and then I see the result. So we have in return dim, which says that it's 3 rows and 2 columns. Then we have empty dim names. First element null, and dim name second element the name of rows A and pi. Sorry, the name of columns. The name of rows are absent, so thus we have null. And the next, what is important to know the basic operations and integrated functions. Okay, first, of course, when we have some values, we have to assign to particular variables. As in many programming languages, you can use operators assign or equal and assign from the left side and right side. you can use one of them. Next important function is print. Print function for viewing the contents of the objects. So in command line, you can write print and then the name of your variable. In a previous example, we have a matrix X. If I write print X, then I see the printout on my monitor screen and the content of these variables. Okay, then we use single or double quotes to show that the object has a type character. An example, we have a variable msg, and I assign to the string hello. If I print, I put in command line msg and push enter, then we have the contents of this object is word hello. So single or double quotes, you can use either of them. Okay, the next important operator is a column operator used to create integer sequences in increment of 1. And example, if we would like to create sequence like 1, 2, 3, and so on up to 10, I just write 1 column 20 and assign to the variable x and print this variable. I have the sequence from 1 to 20. The next important remark that R is case sensitive. Object names must begin with letters or a dot and constants of letters, of numbers, dots and underscores. Then for comments we use operator, the next operator. So everything from the right of this operator is treated as a comment. Then semi-comment is used for separating expressions in one line. And then the sign of two spaces, the operator is used to transfer the code expression to another string. These were important elements of R that may significantly simplify your works. Okay, then we go to next important structures, and we start with vectors. A vector can contain object of only one atomic class. A vector can be created using the function C, which is the first letter from combine. Also, you can use other reserved R functions like vector, seq, rip, and the operator semicolon. An example in this box. In the first line, I create vector of two numeric elements with help of function C. So you see C 0.5, 0.6. Then the next string creates me a vector of two elements with object of logical structure, true and false. And the third line creates a sequence of integer. So the function vector is used to create empty or zero vector. And its function uses two parameters. Mode, which says what type of atomic object you can create, like in this example, it's numeric. Then the next parameter says the length of this vector, like 2 elements, 3. So I created here vector L, which is of numeric type and contains 2 elements, 2 zeros. An example of seq functions, which is also used for creating a vector of consecutive numbers, is seq. An example you can see here. So it has 3 input parameters. So first 2 says from which element I should start, and then the ending element, like here, from 1 to 5, and then by step 0.5. An example from you don't need to write all the abbreviation of the parameter names, like from to by. If you just write the order, it's enough. From 1 to 5 with step 0.5. Okay, one more additional example of situations that you often need in your analysis is creating vectors which contains the same elements, like symbolic elements, and then you can use function rep. So this function is used for creating a vector consisting of the same element, like we assign rep with a parameter test and number 5. It means that we create a vector of size 5, each element of which contains symbolic test string. So we have 1, 2, 3, 4, 5. Okay, then we go to matrices. Matrix, this is a special type of vector in R which has an attribute dim. So the dim is a vector of class integer containing just 2 elements. So the first element is n row, the number of rows, and the second element is n col, which shows the number of columns. And an example. So I create matrix M with help of function matrix. I say the dimension of this 2 by 3, so it means m row is equal to 2 and col is equal to 3. So I have then a matrix by size 2 by 3, and of course it will be empty matrix, and by default in R it will be assigned to values of NA. If I write in the next line function dim of M, then I will get the answer about the dimensionality of my matrix. It's 2 and 3. And then the same you can do with function attributes, so which results in attribute dim. Okay, the functions that I already showed in my previous example was matrix. Now let's consider this in more detail. So the syntax of these functions is matrix, and then it has three entrance parameters: data and row and columns. So this function is used to create a matrix of given size. So the matrices are filled according to the rules, from top to bottom, from left to the right. So what does it mean? If we make matrix from 6 numbers, 1, 2, 3, 4, 5, and we would like to put these numbers in a shape of matrix by size 2 rows and 3 columns, then we have the result like this. So we go from top 1, 2 to bottom, then from left to the right, 3, 4, 5, 6. So this is an example which shows how to create matrices from your data set. Okay, matrix can be created directly from the vector by setting the attribute assignment dim. So let's assume I created vector M, which contains numbers 1, 2, 3 up to 10. You see here the resulting operation. Then I just change the dimensionality of this vector by assigning with functions C and its arguments 2 and 5. Then it's not anymore vector, it's matrix. And then you can see, so I have matrix dimension of it 2 rows by 5 columns, and my data will be rearranged from vector to data matrix. The next important data structure is list. A list is a special type of vector that combines objects of different classes. Each element can be a vector, matrix, vector, or other list. And functions which is used to produce object of type list is list. So the function for combining objects into a list. And an example. So I create a list from elements 1, A, and true. So we have here 3 different objects of type numeric, character, and logical. And so we have list X. If I print, so then you can see the contents of this data object list, of type list. The next data structure is factor or factors. Factor is a special class of vectors which is designed to store codes of the corresponding levels of nominal characteristic or class label. The factor can be considered as a vector of class integer where each element represents a class label. This is often used in ANOVA analysis. So we use function factor for creating factors or combining objects into a factor. Its argument is vector of class character. And there is an example. So we create a factor which will be assigned to the variable x, and we use a function factor. So we use function c, and then the values yes, yes, no, yes, yes, no. So then we have formed variable x of data structure factor, and you can print this, and you will see the content of these variables and levels of these variables. Okay, and typical data structure which is used by data analysts, data mining specialists, people who work with data. It's a data structure data frame. So data frame is a special type of list in which each element has a fixed length. It's used to store tabulated data. Each column can represent different types of data, including factors. Data frame has a special attribute, row names, that specifies the names of the strings. This helps significantly to simplify the data annotation. You can create data frame directly from your data, just use functions read.table and read.csv. Or if you need to create data frame from your script, you use just function data frame. So to create a matrix from data frame, use the function data.matrix or smatrix. And the mentioned function data.frame, data frame, to create data frame. An example. So I use this function to create data frame from this data. The first one has a name foo, and it contains vector of 4 elements, 1, 2, 3, and 4. Second column will be in my data frame has a name bar and will contain 4 logical elements T, T, F, F, which are short names from the logical true and false. So if I print this data frame, you can see then the ending results. So using the functions nrow and call, you can estimate number of rows and number of columns in created data set, data frame. Okay, we go to the third question, which is devoted to the Bioconductor project. And Bioconductor project is open source and open development project based on R statistical programming language. It provides huge tools for the analysis and comprehension of high throughput genomic data. So you can see the website, you can easily find this on internet. And here you can see the main publications which are devoted to description of this project Bioconductor. For further reading, you can use this paper to be prepared for our summer school. So Bioconductor has 2 releases each year, and according to 21st of November 2017, it contained more than 1,300 software packages, and you can find many packages which can be applied directly for solving your work if you work in bioinformatics, biology, system biology, or biomedicine. Okay, each software package has a specific page where you can find this all needed information for this package. So you can see package statistics, brief description of the package, and then rules how to install, documentation links, package detail, and package archives and updates. To install the Bioconductor or one of related packages is quite easy. You can use our commands in command lines like source, download a specific package or full installation, Bioc Lite, or alternative approach. They are shown here. I will not comment this in detail. So you can use these lines directly to download the package that you need, and it's indeed very convenient. So, and there are various facilities on support of Bioconductor users. So each software package is accompanied by a standard manual which includes detailed descriptions of functions and arguments of functions. So frequently asked questions you can find on the web. So Bioconductor support site is shown in this line. So Bioconductor provides training in computational and statistical methods for data analysis based of genomic data. You can see some helpful links. Bioconductor provides detailed description of basic and advanced workflows, the next links, and of course you can find a series of videos on YouTube or in different publications like here from this website. Okay, so I tried to summarize the basic materials that we will need during our summer course. So we will study a little bit more on R package, on R programming. So the main principles and organization of the package are considered, and basic atomic classes for data structures are integer, numeric, logical, character, complex. The basic data objects are vector, matrices, lists, factors, and data frames. The open source and development project Bioconductor exists, so you can use it, and it integrates huge tools for data analysis and comprehension of high-throughput genomic data, which is very helpful for work in bioinformatics, for example. For further reading, I would suggest the next literature sources devoted to programming, to the programming language R. So very helpful books and courses or manuals. So I would like to thank you for your kind attention. So you're all welcome for our summer school in August 2018. Thank you and goodbye.